So in this current problem, we are looking at the region bounded by three lines. So please take a look. The current region drawn is actually bounded by the three lines x, y equals square root of x, y equals 0, and x equals 4. So please take a look at the blue shaded region bounded by the three lines. And now I'm taking the axis of rotation to be x equals 6 to be the axis. So I'm talking about the red line as the axis of rotation, which is x equals 6. So before talking about the correct volume formula for the solid now generated by the blue region rotated along the axis x equals 6. Before that, let's look at the solid that we are getting. If you do this rotation vertically along this red axis, so I'm trying to sketch the kind of solid that we can get based on this rotation along this line, which is x equals 6, right? So to be more precise, we actually have a black x-axis here, like this. And you can see the kind of solid we are getting is something like this. So I understand that my sketch is not accurate, but I hope you can visualize what kind of solid you're getting. The fact is that it is not a full solid because there's a big empty part that you need to cut out, right, from the middle of the blue solid. So this green empty part corresponds to this white part from the red axis to the blue solid. And anyway, we can make a remark. It is not a full solid, right? So let's focus on the current solid that you're getting. Let's say to get the volume formula, we try to use the washer method. And by the method of washer, we have to understand what we are trying to do is like we are trying to get the outer volume minus the inner volume, like this, something like this. So there's one thing we need to fix. Is it the dx integration or the y integration? The only thing that you need to keep in your mind is that because the direction of the axis is parallel to the y-axis, for the method of washer, we always have to do the y integration. It's always like this. And because of the fact that it is the y integration, the AB, which corresponds to the lower and upper limits on the integral sign, should go along the y-axis because it is a y integration, right? So let's go back to the picture at the top left. If you go along the y-axis for the current blue picture we have to look at the lowest point, uppermost points are bounded by the region. And clearly, the A is 0, right? Clearly, because it's the origin. And for the y value of the uppermost point, it is our B. And do you know how to find the B? B is actually, if you look at this picture, B is actually the y coordinate of the intersection two lines. So let's find B first. So take a look at the green color on this part of the page. The B is the y coordinate of the intersection of two lines, y equals square root of x and x equals 4. So we can just solve these two equations. X is 4 can be put into y equals square root of x. So essentially, you're solving the equation y equals square root of 4, which is 2, right? So basically, our b is 2. So let me put it back into our formula first. So essentially, now the integration is from 0 to 2, you can see. So the remaining part to understand is about the outer radius, which is this part inside the formula, and the inner radius, right? And now let's think about what do I mean by the outer solid. The outer solid corresponds to the whole thing, basically. So I'm talking about the whole solid, which is full. I'm talking about the full solid by pretending that the green empty part is actually full with the blue liquid. So this is our outer solid. Look at the way we form the outer solid. Which line we used to get the outer solid? I think clearly it is this line, right? Clearly. And this line is y equals square root of x. Think about this. This is the line we have. Y equals square root of x. And what do I mean by outer radius? Please think about that. The outer radius is basically the radius of the cross section of the blue solid. So I'm trying to sketch just one cross section inside the blue solid, and the outer radius is basically this radius. This is the outer radius. This is the radius of the cross-sectional area of the blue circular section, right? So if you go back to the top picture, let's go back there. If you go back to the top picture, the outer radius of certain section is essentially the length of the horizontal purple line I just sketched from the axis all the way up to the outer line, right? The outer line is what? Is y equals square root of x. And what is the length of this purple line? Think about this. Essentially, the length of the purple line is the whole thing, the full length from the x-axis to the line x equals 6. This length must be 6, right? Because we push basically the y-axis all the way to the line x equals 6. There's a distance of 6 units. These 6 units, we need to subtract a blue part here from the red part. I hope you get my point. What is the length of this part? This length is the horizontal length of this point on the curve y equals square root of x. So what does it mean is that we need the expressions x equals g of y to represent the x value of this point. And let me write it down on the right hand side. So please look at the right hand side of the board. We originally have the outer line y equals square root of x. We need the expression x in terms of y. So automatically the expression is x equals y squared, right? This y squared represents what? If you come back to this picture, this y squared represents just the length that we need to subtract from the whole red line. And we get the length of the horizontal purple line by using 6, the whole length 6, and minus basically the black part, which is what we call it x equals y squared, right? X equals y squared. So x equals y squared is what we have for the outer radius, if you get my point. And how about the inner radius? We do the same thing here. So essentially, the inner solid represents the green solid that we need to cut out from the whole solid, right? And we have to look at the meaning of the inner radius now. The inner radius is essentially the radius of the circular sections here. And what is this length in green? Let's come back to the picture at the top. So for green length, the same solution can help. The way we got the outer radius is we use this whole length, the red, which is 6. The whole thing is 6, minus what we have for the length, which correspond to the x value of this point on the inner line. If you come down back to this picture, this inner line that we used to draw the inner solid is x equals 4, right? So essentially it means what? It means our inner solid is basically 6 minus what we have from the inner line. The inner line is 4, basically. So, or you can say the inner radius is basically 2 as a constant, which makes sense because if you look at the green solid, it is clearly a cylinder, right? A cylinder means the circular section stays unchanged. The radius of a circular section also remains unchanged. So if you want one more remark, the y square represents the line x equals y squared. The second term in the inner solid represent the line, the inner line, which is x equals 4. Yeah. So basically, let me write down the final answer as a formula to find the volume of the solid. So it should be the formula that can help us find the volume of the solid. And that's the end of this video.